This is example D on page 13. So I'm doing this for the recording, okay. So we're using the ratio test and setting it up. So we have our x to the k plus 1 over 3 to the k plus 1, and then 3 to the k, and then k plus 1 all over k plus 2, x to the k. Okay, so you expand that, and this is what you end up getting. And I just lined up all of the terms. So this will cancel out, this will cancel out. And then I'm going to pull out anything that is not affected by the k, so that will be the absolute value of k over 3. And then I'll take this limit. And so since the powers are equal, that means that it goes to 1. And so I'm going to rewrite the absolute value of x over 3 as a 1/3, and then absolute value of 3. And then that's going to be less than 1. And anytime you have an absolute value, you want to isolate that first before you split it up as an inequality. And so I'm multiplying through by 3, and so I get the absolute value of x is less than 3, and so this would be the integral. All right, so I think that's where we left off. So then the next part is now testing out the endpoints. So I have to write the endpoints. So this kind of medium case requires the most work, because not only do you have to find the interval, but you also have to do the endpoints. So I have x is equal to -3, and so you're always going to go back up here. Now, when you put this back up into the sigma notation, you have to include this alternator. Right, so prior to that, we were just using the absolute value, but in this case, I'm putting in a -3 into this x here, but then I have to include this -1 to the k power. Okay, so then it's going to be summation, and this will stay as -1 to the k, and then I'm putting in a -3 in for x, so it's -3 raised to the k power all over 3 to the k times k plus 1. And that's as k goes to 0 out to infinity. All right, how can we simplify this? Of what? Of this one here? Okay, so I guess I could rewrite this as
-1k.
Yes, -1 to the k and a
3
to the k. Yes. So I'll just write that on top. And so then this will cancel out with this. And then I'm going to now simplify this a little bit more. So I have a -1 to the k times a -1 to the k. What does that become? -1 to the 2k. And then in the denominator, I'll have k plus 1. Okay, so k equals 0 out to infinity. All right, what is a -1 to the 2k? 1. Right, because it's an even, so this is always, it's an even, so it's going to be always a positive 1. So it's always going to be a positive 1. Right? Because it's anything that the even power is going to be a positive 1. So then I can simplify it to this, being k is equal to 0 out to infinity. So it's going to be 1 over a k plus 1. Okay, and then what happens to that one? All those 10 tests. What? Yeah, poly test. So we'll say, bless you, poly test. And just a quick review, you want n plus 1 in comparison to d. So this is going to be 1 compared to 1, and we know that when it is, what's the inequality here? Greater than or equal to, greater than or equal to, therefore it diverges. All right, so then we know that it's not going to include a -3. How about at x is equal to 3? So then this will now be k is equal to 0 out to infinity. And so then you'll have -1 to the k power and 3 to the k all over 3 to the k times a k plus 1. So this one is going to cancel with this. So then the alternator here will still stay. So it's k equals to 0, infinity, -1 to the k all over k plus 1. All right, what happens with that one? Well, if there's an alternator, you actually have to go through this whole process, if you remember. So you have to take the absolute value and then determine, does it converge or diverge? So what happens with this absolute value, on the absolute value test? It diverges, and then if it diverges, then you have to use the alternate series test, and what happens? Yes, so this one, it's going to be a conditionally convergent, and I'm just going to state, okay, we're running a little low on time, so I'll just say you need to show this. Show this. All right, so you'll do the absolute value and then show that. So conditionally convergent is still convergent, so now we're going to include this. So now I can write out my final answer. So the interval of convergence is going to be -3 less than x less than or equal to 3. Since it converges on this one, I'm going to include that. And then the radius is going to equal what? What's the radius of convergence on this? 3, whatever that number there is. Okay, so then if I were to look at this, it's a Maclaurin series, so it's starting at 0. So it's going all the way to 3 to -3. It does not include this. It does include this, and it's going to be good for all of this region. All right, so if I were to ask you to put this in a graph, whatever this series comes out to be in terms of expanding it, I keep going more and more, and it'll be very good between a -3 and 3. Beyond that, it will not be a good fit. All right, so it'll be obeying here and disobeying anywhere else. No matter how hard you try, it will not work. Okay. All right, any questions on that, on the power series? Okay, then for the next part, it's still a power series, but now we're going to concentrate on looking at it when it is centered, not at 0, but somewhere else. So power series and x, and then minus x sub 0. So this is basically your Taylor series. So previous to that, we were looking at the Maclaurin series, and now we're looking at the power. All right, I'm not going to read through this entire thing. It's exactly the same as what we just talked about, right? So you've got your 3 scenarios. I'll just quickly highlight it. So your 3 scenarios are, it's either going to be equal to that particular point. So this point is any number now, right? So it could be 5, it could be 7, any number. It doesn't necessarily have to be 0. And then, so it could be just good at that one particular point, or it could be good everywhere, which is a real good scenario, or it's going to be converging, series converges absolutely for all x in some interval of this. And notice here that now we're considering the fact that it is not starting at 0. So it's not going to be a negative r to r, it's going to be wherever your center is, you're going to add on to it, and wherever the center is, you're going to subtract. All right, so for example, say that you had, I'll just give a number, say that your center is at 3, then it could go maybe one distance this way and another distance this way. So that interval would be the interval that you're talking about. So say that the radius was 2, then it would be like 5 here, and then 1 right here. Okay, so you're just taking it away from the center, right? That's basically what this next part is. Okay, so I think I have 2